Hello friends, welcome to this session of maths. Today we are going to look at statistics. So one of the basic concepts of statistics is arithmetic mean. You may be simply knowing it as average. Arithmetic mean is the same thing as average. It is a sum of all items divided by the number of items. So let's say for an example, what is going to be the average of this or arithmetic mean of this set of numbers? What we do is we just add those numbers together. If you add them, you'll get 402. And how many numbers we have? We have 10 numbers. So arithmetic mean is going to be 402 divided by 10, 40.2. It is as simple as that. Some basic observations about arithmetic mean. The mean may or may not be a term in the set. So let's take an example. Let's look at this set 10, 11, 12. What is going to be the mean? It's going to be 10 plus 11 plus 12. It's going to be 33. 33 by 3, we are going to get 11. Right? So 11 is a term in the set. Now let's take another example 10, 11 and let's say 14. What is going to be the sum? The sum is going to be 35. 35 by 3, so we are going to get 11.66. So 11.66, the mean is not a term in the set. So both cases are possible. The mean may or may not be a term in the set. If all the terms in a set are increased or decreased by the same value x, then the mean also increases or decreases by x. Now here, let's say we have A, B and C as three terms, and we add x to each term, B plus x, C plus x. This is another set. Okay. What is going to be the mean of this? The mean is going to be A plus B plus C by 3. Right? Here the mean is going to be A plus B plus C plus 3x divided by 3. Correct? So which is going to be A plus B plus C by 3 plus 3x by 3 plus x. Correct? So if we add x to every individual term, the mean also increases or decreases by x. So if it is plus x, if you are adding x, the mean is original mean plus x. If you are decreasing x, A minus x, B minus x, C minus x, the mean is going to be A plus B by 3 minus x. If all the terms are multiplied or divided by x, then the mean also gets multiplied or divided. So let's take this example again. So we know A plus B plus A comma B comma C, the mean is going to be A plus B plus C by 3. Now let's consider AX, BX and CX, and let's consider that mean. So that is going to be AX plus BX plus CX, which is going to be x into A plus B plus C, right, divided by 3. So you will see that the original mean is now multiplied by x. So when you multiply or divide every individual item by x, the mean also gets multiplied or divided. Mean may be greater than or less than median or mode for the given set. So what are median and mode? We'll see them in the next slides, but you can for now you can just remember that mean may be greater or less than the median or mode. Same thing with median or mode also. The median and mode can be greater than the mean. So basically all the three, mean, mode, median, are independent of each other. There is not going to be any relationship with respect to which one is always greater or which one is always smaller. Median is the middle value separating the greater and lesser halves of a set. So let's look at it. Let's say we have values 10, 11, 13. So what we do is, to find the median, first arrange the terms in increasing or decreasing order. So this set is already arranged in increasing order, right? If the number of terms in the set is odd, how many items we have here in this set? We have 3. So this is odd, right? So number of terms in the set is odd. the median is n plus 1 by 2, the term at n plus 1 by 2. What is n? N is equal to 3 in this case. How many terms we have? That is n. So we are going to have 3 plus 1 by 2, that is 4 by 2, that means second term. So second term is going to be the median. If the number of terms in the set is even, let's say we are talking about this set 10, 11, 12 and 13. Okay, now how many people, how many terms we have? We have n is equal to 4. This is even. So the median is going to be n by 2th. The median is going to be the mean of n by 2th and n by 2 plus 1th. So what is n? N is equal to 4. So n by 2 is 2, that means second, and n by 2 plus 1 is third. So it's going to be the mean of second and third item. So second and third item are these. So the mean of that is going to be 11.5. So some observation or some examples. Let's say find the median of this set. So first thing, step 1, arrange in increasing order. So we have some negative numbers, minus 100, minus 20. So we put them in increasing order. It is also fine if you put them in decreasing order. Number of terms 11. So 11 is odd. So what do? We just look at n plus 1 by 2. This much we calculate. So that becomes 12 by 2 is equal to 6. So we look at the sixth term. What is the sixth term in the arranged set? 1, 2, 3, 4, 5, 6. Sixth term is 10. It is possible that, see, it doesn't matter whether there are two terms of the same value. It doesn't really matter. We can have that is perfectly fine. But here in this question we are worried only about sixth term. So we look at 1, 2, 3, 4, 5, 6. Example 2. Let's look at this set. We arrange them in increasing order. Number of terms is equal to 10. So that is an even number. So now we are worried about n by 2 and n by 2 plus 1th term. So n by 2 is 5 and n by 2 plus 1 is 6. So we are going to take the mean of 5th term and 6th term. So what is 5th term? 1, 2, 3, 4, 5. 6th term, this. So what is the mean of this? 10 plus 25, 20 plus 15 by 2, 25 by 2 is 12.5. So the medium is 12.5. Some observations. Median may or may not be a term in the set. Here we saw that 12.5 is the median. 12.5 is not there in the set, right? So it doesn't matter. Median may or may not be in the set. Depends on whether the number of terms is even or odd. So here we have number of terms is 10. So that's why the 12.5 is not there in the set. Whereas here number of terms were odd, and we are looking at the sixth term. The sixth term is 10, and that exists in the set. So if the number of terms is odd, we are going to see that median is going to exist in the set. If the number of terms is even, we'll see that the median does not exist in the set. If all the terms in the set are increased or decreased by the same value, the median also increases or decreases by the same value. You can try it for yourself. We have already seen how to prove this in the example of mean. So I encourage that you try this on your own and see if this is true. If all the terms in a set are multiplied or divided by the same value x, then the median also gets multiplied or divided by the same value x. You can try this on your own again. Median may be greater or less than mean or mode of the set. So again, mean, median, mode, all these three quantities do not necessarily have to have any relationship with respect to which one is greater or which one is greatest or which one is smallest. Mode is the most frequent observation. So one thing to remember is mode, MO, is equal to most, MO. So this is like a mnemonic you can use just to avoid any confusion. So mode is the most frequently seen observation. So here we'll calculate which of the term is most like no most coming for most number of times. So you will see that 10 is coming once, 7 is stem is coming 1 2 2 times, right? 7 is coming once, 5 is coming once, minus 2 20 is coming once, 15 is coming once, 25 is coming once. All these terms are coming only once. Only 10 is coming twice, so the mode is 10. Some observations regarding mode. Mode may or may not be a unique term in a given set. For example, if you're looking at this set, let's say if you had another 7 here, the mode is also going to be 7. So mode is going to be 10 and 7 both, right? Different terms may have the same frequency. Like in the earlier example, we saw 10 and 7 both coming twice. So it has two modes. That particular set has two modes. Such sets are called multimodal sets. If all the terms in the set are increased, decreased by the same value x, the mode also increases or decreases by same value x. Similar to what we have seen in mean and median. I encourage you that you try to prove this on your own. If all the terms are multiplied divided by the same value x, the mode also gets multiplied or divided by same value x. This also you can try on your own. Mode may be greater than or less than median or mean. So again we are seeing that mean, mode and median do not have any relationship among them. Standard deviation, one of the most fundamental concepts of statistics. Standard deviation, as the word says, is going to talk something about the deviation. So it is defined as measurement of variability or diversity in a set. So what it shows is how individual values are deviating from the average. So you will have one particular value for a given set, one particular value is the standard deviation of the given set, and that deviation will tell us about how individual values are different from the average. Practically what it means is standard deviation, if you have high standard deviation, it means if individual values are more likely to be far from average than a similar set with low standard deviation. So higher the standard deviation, higher is the variation among data values, which means that the scores are highly scattered. For example, let's say 100, 10, 11, 12, 13, 14. This is going to have less, small standard deviation as compared to a set like this. 10, 15, 25, 1000, that way. You will see that the mean is going to be much higher in value, whereas here the mean is going to be 12, here the mean is going to be much higher, and individual values are also very, very, very far from that mean. So that means this set has higher value, standard deviation, this set has low standard deviation. So standard deviation, how to calculate? Consider a set consisting of following 8 values. Let's see, we're talking about these sets. Find the average of data points. So let's find the average, we add them up, 1 2 3 4 5 6 7 8. So it comes out to be 40. The average is 40 by 8 is equal to 5. Okay, compute the difference of each data point from the mean. So we are going to calculate this data point, mean is 5, and square that for each data point. So 2 minus 5 by square minus 3 square 9. Again 4 minus 5 square, that is 1. 4 minus 5 square, 4 minus 5 square, 5 minus 5 square, 5 minus 5 square, 7 minus 5 square, 9 minus 5 square. So we get the squares for all individual item. How do we get that? We subtract the mean from every item and take the square of that. So now we have these 8 values, we have these many values. So what we do is, now we take the average of those values and take a square root of that. So take the average of these values, there are going to be 8 values, so we take the average divided by 8, we take the root. So the root comes out to be 2. The standard deviation of this set is 2. So this is considered as the standard deviation of the set. So once again, quickly, we find out the arithmetic mean, we subtract every individual the arithmetic mean from every individual item, we take the square of those values. So we'll have as many values as there are terms in the set. So here we have 8 values. We take the mean of those 8 values and take a square root. That comes out to be the standard deviation. Some observation. Now these observations are not similar to the observations for mean, mode and median. If all the terms in the set are increased by a value x, the standard deviation remains the same. Now look at it this way. What we are saying is standard deviation talks about how the individual values are how far the individual values are from the average point, right? So let's say we're talking about 10, 11, 12, okay, and now we add 10 to each value. Let's say 20, 21 and 22. You will see that in this the mean is going to be 11, in this the mean is going to be 21. So numerically they are different, but how far is the mean from individual values? It is, individually it is 1 units away. Here also individually it is 1 units away. So long as we haven't changed the relative composition of the set, that means so long as we have only increased every individual value of the set or decrease every individual value of the set by a constant number x, here x is equal to 10. If we do that, we are not changing the set with respect to how they are, how relatively they are arranged. So here the relative arrangement remains the same, here the relative arrangement remains the same. So that is why the standard deviation does not change. If all the terms in the set are decreased by value x, same thing. If we had written, say, if we subtract 5 from here, so we get 5, 6 and 7, right? Here also the mean is 6, value is just different, but individually it is only 1 unit away from, so all these 3 are going to have the same standard deviation. If all the terms in the set are multiplied by value x, then standard deviation gets multiplied by x, and if all the terms are divided by value x, the standard deviation gets divided by value x. So these two, multiplication and division, are similar to mean, median and mode, whereas addition and subtraction are different. Some other terms, range. Range is the difference between greatest and smallest element in a set. For example, let's consider this set. Let's find out the greatest and smallest element. So greatest element is 200, smallest element is minus 100, and how far they are, 200 and minus 100, they are 300 units away. So that becomes the range. Variation is defined as square of standard deviation. So variation is equal to standard deviation square. You will see that variation also tends to exhibit these qualities. So let's look at practice problem 1. Please pause the video and give it a try. The highest term in a set is 3 standard deviation above the mean. The lowest term is 4 standard deviations below the mean. If the highest term is 200 and the range is 140, then find standard deviation, lowest term and mean. Okay. So let's see, what do we know about the set? We know that the highest term is 200. Okay, so let's say highest term is equal to 200. The range is 140. Now range is always going to be highest term minus lowest term, right? So that means lowest term is going to be 140 minus 200, correct? So that's going to be 60. So lowest term is 60. We got it. Okay. Also, what does it say? Highest term is set in a set is 3 standard deviations above the mean. Okay, let's say we have M is the mean and SD as standard deviation. So we know highest term is equal to 3 standard deviations above the mean. So mean plus 3 standard deviation, and lowest term is 4 standard deviation below the mean. So it's mean minus 4 standard deviation, right? So let's put values for HD. HD is 200, LT is 60. Okay. So let's subtract one equation from another. Let's subtract this equation from this one. So what do we get? So m and n get cancelled. What do we get is we get 3 SD minus 4 SD, that is 7 SD, is equal to 200 minus 60. This is 140. So standard deviation comes out to be 20. Okay, so we get standard deviation. What is going to be the mean? Let's put value of standard deviation in one of these equations. What do we get? We get mean plus 3 times standard deviation, which is 60, is going to be equal to 200. So that means mean comes out to be 140. So 140. Let's move to this problem. Please pause the video and give it a try. The average weight of students in a class of 25 was 100 pounds. Okay. After 5 new students joined, the average weight became 110 pounds. Okay. So you will see that the average is increasing. That means these 5 students must be heavier than other students, right? Or rather heavier than the average of other students. What is the average of the average weight of the 5 new students? Okay. So let's look at it. Let's say sum of, what is going to be the sum of first 25 students? Is going to be the average into 25, right? So average is 100 and 25. So the average, the sum of weights of, sorry, this is weights of, sum of weights of 25 students is going to be 2500. Now we have 5 new students. So how many students we are going to have? We are going to have now 30 students. Okay, and what is going to be the sum of that 30 students? Sum of weights of those 30 students is going to be 110 into 30, right? 110 into 30 is equal to 3300, right? So you will see that the total sum of students, weights of students, increased from 2500 to 3300. So there is an increase of 800 pounds because of 5 students. 800 pounds is the sum of weights of new 5 students, correct? So what is going to be the average weight? So it's going to be sum divided by number of students. It's going to be 800 by 5. So it's going to be 160 pounds. So the average of those 5 students is 160 pounds. Let's move to this problem. Pretty interesting problem. Please give it a try. The average age of 100 nurses in a hospital in 1990 was 50 years. Okay. So let's make this table. Nurses. How many nurses we have? We have 100 nurses. This is year. We have year 1990. 100 nurses. This is the average age. Average age was 50, and this is, let's say, total age. So total age was 5000. We don't really need total age, but this is just for the sake of understanding. So this 100 into 50 is total age 5000. Okay. Now you will see that in 1991 every nurse would have got older by a year, right? So that means the average age is going to be 51. Same number of nurses. So total age would accordingly become 5100. Right? So like this, every year one is going to get added. So that means the first question is 1991, what was the average age? 1991, the average age was 51 years. Now an event happens in 1994. Okay. What happens? 20 nurses retired at an average age of 60. Okay. So let's say this is start of 1994. In the start of 1994, we still have 100 nurses, and they are going to have 54 years as the average age. Correct? 54 years as average age, because 4 years get added to the average age of 1990. Right? So that is basically about 54 100 total age, right? Out of these 100, now there are 20 nurses with an average age of 60 who get retired now. Okay, so how much is that going to affect this total age? Now this 20 into 60 is going to be 1200, right? So this much, these nurses are not there, so we are left with 80 nurses. What is going to be the average age of those nurses? We know that now the total age is going to be 5400 minus 1200, correct? 5400 minus 1200, so it's going to be 4200. So these 80 nurses have X as average age, and their sum of ages is 4200. That means X is going to be equal to 4200 divided by 80, correct? So X is going to be 4200 divided by 80, correct? So it comes out to be 52.5. Now you will see that the average age suddenly has decreased. Now intuitively, see, one thing you should catch is that at the start of the year we had 54 as the average age, out of which there are some nurses that are obviously greater than 54, aged more than 54. There are some younger nurses also. 20 nurses get retired, so that means older nurses get retired. Anyway, their average is given as 60. So that means the average age is now going to drop because older nurses have got retired, right? And you will see that now average age is 52.5. Suddenly it has dropped by 1.5 years. So this is at the end of 1994. Next event is in 2000. So from 1994 till 2000, the same average age is going to continue, just that it will increase by 1 year. So in 2000, start of 2000, we still have 80 nurses, and their average age is now, what is the time span here? We are talking about 6 years. So now they average age has gone up by 6 years here, right? And what is going to be this total sum of ages is going to be 80 into 58.5, correct? So it's going to be 80 into 58.5, which is basically 585 into 585 into 8, correct? So that comes out to be 5680. That is 5680. Now something happens again. 40 nurses joined at an average age of 25 years. So we have new 40 nurses, average age of 25 years. So what is going to be the total of age of these nurses? These nurses, the total age is going to be 25 into 40 is going to be 1000. Now for these 120 nurses, now what is going to be the average? The average is going to be sum of this divided by 120, which is 6680 divided by 120, which comes out to be 47.33. Okay, now we have all the data. 1991, what was the age? We have the age was 51. We have already seen that. 1996, what was the age? 1996 is somewhere here, right? And 1996 average age is going to be 1994 average age plus 2 years. So 1996 average age is going to be 52.5 plus 2, which is 54.5. Okay, 2000, at the end of 2000, what is going to be the average age? The average age, like we saw here, is going to be 47.33. It's a pretty interesting problem. If you require, you can revise the problem by rewinding the video. The main concept here in this problem was to understand the composition of nurses, assigning their an average weight, and then splitting out the bunch of nurses with different average age. And then we are using total age as a parameter that will help us in figuring out the average of the new set of nurses. Let's look at this problem. Please try it on your own. "30 students decided to buy an article At the last moment, 5 students backed out, because of which every student had to pay $16 extra. What was the cost of the article? Let's say 30 students are buying, everyone is contributing X, and the cost of the items becomes 30X. Correct? There are 30 students, everyone is paying X dollars, and the total item cost is 30X. Now 5 people back out, so now we have 25 students only. Obviously now everyone have to pay a little higher, right? So how much higher they have to pay now? So now they have to pay $16 extra, so it's going to be $16 extra. The cost of the article anyway remains the same. Correct? So we get this equation. Let's solve that for X. So we get 25X plus 400 is equal to 30X. So that means 5X is equal to 400. Correct? So X is equal to 5X is equal to 400. That gives us X is equal to 80. And what is the price of the article? Cost of the article is 30X. So 30X is equal to 30 into 80. It's going to be 2400. So the article's cost is $2,400. Let's put this the numbers back here and see if this makes sense. So if this is going to cost 2400, X is 80, that means 30 students were planning to buy it with contribution of 80, and they were planning to buy it for 2400. Now there are only 25 students and the cost remains the same. So how many of them now how much will every student have to contribute? Every student will have to contribute this much. So that is going to be 24 into 4, 96. We'll see that everyone now has to pay $16 extra. That is what is given. So that means this solution is correct. Let's move to the next problem. Please pause the video and give it a try. XY is a 2-digit number where X and Y represent 2 separate digits. Okay. If the average of 4XY and 2YX is 33, what is the average of X and Y? Okay, so XY is a 2-digit problem. So that means, 2-digit number. That means if it is 12, so that means X is going to be equal to 1 and Y is going to be equal to 2. So XY can actually be written as 10X plus Y, right? This is a very important concept. So XY can actually be written as 10X plus Y. And we know the average of 4XY and 2YX is 33. So average of 4XY, XY is 10X plus Y, and 2YX, YX is going to be 10Y plus X. The average of these two is equal to 33. Okay, so let's solve this. What do we get? 40X plus 4Y plus 20Y plus 2X is equal to 66. So let's combine all these X terms together. What do you get? 42X plus 24Y is equal to 66. Correct? So let's divide by 6. So what do we get? 7X plus 4Y is equal to 11. This is the only information we have. Now you will say this equation is not solvable. Yeah, it appears to be, because we have two variables and we have only one equation. We can never solve that. But here one thing that is important is that X and Y are two individual digits. So X is only going to take value from 0, 1, 2, 3 like that till 9, and Y is also going to take values from 0, 1, 2, 3 like that till 9. And you will see that 7X plus 4Y is equal to 11. The only combination that can take values of X from this set and value of Y from this set and still form this equation, these values are going to be X is equal to 1 and Y is equal to 1. There are no other values that will satisfy this equation. So X and Y both are going to be equal to 1. That means the number we are talking about is 11, right? And the average of that is going to be 1 again. So average is going to be 1. Let's see. Let's put this value back. XY is equal to 11 in this. So XY is equal to 11. So this number is 44. This number is 22. And average of that is 44 plus 22 by 2 is going to be 33 as given. So that means our solution is correct. So with that, we come to an end of this session. I hope you enjoyed it. I look forward to meeting you in the next class. Thank you.